The Helios isn't just another weapon, it is the ultimate destroyer, generating enough power to vaporize any target in seconds. It has no gunpowder, no magazines, and no projectiles. It is just a single burst of energy that neutralizes drones from miles away. What we're used to seeing in science fiction movies has now been brought to reality by the United States Navy, which is why I cannot hide this secret from you. So today, we're going to be revealing how the Helios was conceived, developed, and even tested. And by the end of this video, you will understand how this single piece of technology can change the art of warfare for life. Let's blast in. The $150 million Annihilator. Since the invention of the machine gun, few military technologies have represented a true, paradigm-shifting leap forward. But now, the Helios system has become the next machine gun of the future. Mounted on the Arleigh Burke-class destroyer, the USS Preble, it is not merely an upgrade, but a revolutionary weapon that is poised to change naval warfare forever. Unlike warfare of the past, today's enemies are defined by cheap, disposable drones, saturation missile attacks, and fast-moving asymmetrical threats. Their aim is not to overpower our carriers, but to bankrupt them, forcing the use of expensive $2 million SM-2 defense missiles just to intercept $5,000 consumer-grade drones. But now, the Helios system has been created, tested, and it is ready to prove itself as the ultimate defense against these incoming swarms. With an initial power output of 60 kilowatts, but scalable to 150 kilowatts, the Helios offers an unlimited magazine, speed of light engagement, and a cost per hour that is the price of a cup of coffee. But its genius doesn't just lie in the killing blow. It is the nature of the system that can perform 3 tasks at once. It is a sniper rifle, a precision jammer, and a high-definition thermal eye, all linked into the legendary Aegis combat system. This isn't just a replacement for the close-in weapon system, CIWS, but the nerve center of a new form of defense installed in the vacant forward CIWS mount on the USS Preble, a masterpiece of naval engineering, plugging into an energy grid that was designed for this exact technological leap. Now, I know I've said so many things that already sound like crap, and you're probably asking, has this thing even been tested? Well, let's find out. Making naval history, the live fire demonstration. As impressive as all these features sound, if it doesn't work in practice, there is no reason to use them. For the Helios, the moment of truth came during a classified live fire demonstration reported in 2024 and confirmed by the Pentagon's Director, Operational Test and Evaluation Report, DOE. The report suggests that somewhere in the Western Pacific, the crew of the USS Preble steamed toward a target area. Their mission? Locate, track, and shoot down an incoming hostile drone. It is assumed the Navy used spec models of what they'd expect from enemies such as Russia and China. After days of sailing, it finally reached the operational box, while the atmosphere in the CIC was thick with tension. Watchers were cautiously monitoring their radar and screen, each person looking for the single radar blip in between the atmospheric clutter. The mission was simple: study the layered defense protocol, while the tactical action officer, Tao, repeatedly ordered watchstanders to check and print suspected tracks. Each sailor rattled off their part of the report. With each passing moment, the electronic warfare specialist reported an electromagnetic signature, and the Tao would confirm the modes and codes. Next, the radar operator focused on the speed and altitude. The meticulous, time-consuming process went on until finally, the Aegis combat system had a solid track. Then, at an undisclosed range, the Preble's spy radar picked up a clean, high-confidence signature of a hostile aircraft. Watchstanders confirmed the track did indeed correlate to the target. Finally, the Tau came on the radio. "We have a track. Confirmed hostile. Requesting batteries release." Then the captain gave the order, and the Tau rolled the final safety measure, a fire inhibit switch, to green. Less than a second later, A beam of light ripped from the bow of the Preble, invisible but undeniable, traveling at 186,000 miles per second. Seconds later, a visible fireball from the drone could be seen as it veered off course, crashing into the ocean. It was a massive success, and the ship erupted in cheers. They had just made naval history. In subsequent tests, the Helios proved vital against fast inshore attack craft, FIAC, as well, while even possibly destroying more heavily armored vehicles. Now you're wondering, how did the Helios find its way to the battleships? The answer might not be what you're expecting. The journey of the Helios. The Helios isn't just a concept born out of necessity. It is a lesson in both technological advancements and practical naval engineering. When the Navy chose to install the Helios on the USS Preble, it wasn't just random, but an elegant solution to the power problem. And as of now, the Preble is the only publicly confirmed ship to deploy the system. A quick look at the Arleigh Burke-class destroyers reveals a design that was originally designed for 2 CWIS units, one forward on the bow and another aft near the helicopter hangar. It is the standard design philosophy that has been followed for decades, providing a full 360-degree defense against any incoming drones or missiles. Yet the Navy chose to scrap installing a second CIWS system on non-ballistic missile defense, BMD-capable ships. It wasn't to accommodate the Helios, which wasn't even a thing yet, but to save costs and shift more responsibility to the longer-range standard missiles, SM-2, SM-6. Because of this, more than half of all U.S. Navy destroyers only have one CIWS, the Mark 15 Phalanx, at the aft mount. It meant that the forward space remained empty, a constant reminder of the original design's ambitions. But when Helios was born, the Navy needed a slot to mount it. This vacant forward spot was perfect. And here's why. First, there's the existing power infrastructure. When the current CIWS is firing its 20mm rounds, at over 4,500 rounds per minute for the modern version, it needs about 18 kilowatts of energy just to power the monitor. If it is used to use the tracking and search mode, this quickly jumps to 70 kilowatts for scanning and engaging targets. It doesn't sound like much, right? But it is enough to power a 3,000 square foot house. For this reason, the vacant front mount already had some of the highest power infrastructure connections on the ship, second only to the main propulsion turbines and spy radar arrays. Thanks to this plug-and-play capability, the Navy saved millions of dollars in having to redesign the entire vessel. Secondly, these connections have the added benefit of allowing the Helios to be directly connected to the ship's Aegis combat system. Currently, Aegis is the most advanced naval command and control system in the world. Essentially, the brain of the ship. By plugging Helios directly into the legacy CIWS interface, the laser is instantly recognized as a firing solution. It becomes a fully integrated weapon that can receive high-fidelity targeting data from the spy radar, be an immediate option for the Tactical Action Officer, TAO, to choose from when engaging a threat, and conduct its 3 different mission sets: hard kill, soft kill, and surveillance, all simultaneously without requiring a separate control console. That sounds like a lot of power, but where does it come from? The destroyer's electrical heart. Each Arleigh Burke-class destroyer is powered by 4 massive General Electric LM2500 gas turbine engines, generating 100,000 to 105,000 shaft horsepower for propulsion. Auxiliary gas turbine generators are installed to generate additional electrical power for the radar, sensors, and weapons. A typical flight IIA DDG like the Preble has 3 Allison AG9140 generators, each capable of producing 3 megawatts, or 3,000 kilowatts of electrical power. And while the current output of the Helios is 60 kilowatts, it uses merely a fraction of the ship's total capacity. What makes the Helios different, though, is that it requires more than just raw power. It requires conditioned, stable, and continuous power, and the infrastructure designed to handle the CIWS, which has intermittent electrical spikes, has proved perfectly suited to manage the high but steady demand of the Helios system. Thanks to this power infrastructure, it gives the Helios its major strategic advantage, since a conventional gun can only fire until the magazine is empty. For the SM-2, this is a capacity of 90 to 96. In its vertical launch system, VLS, it is severely limited, a problem the Helios doesn't have. Since it is a laser, which can fire continuously, if the ship's generators are working, it essentially has an unlimited magazine. So, where the cost of firing a single missile shot is expensive, the price to fire Helios is simply that of the diesel used to fuel the generator for a few seconds. But if you thought this is where the US Navy stops, you'd be drastically misinformed. Since the threat of drones is increasing, and technology advances at such a rapid rate, the system was designed with scalability in mind. When Lockheed Martin developed the Helios system, they introduced spectral beam combining, which allows multiple kilowatt-level fiber lasers to merge precisely into a single, high-quality, high-power beam. It means the Helios will remain an active defense, even as the weapons used by the enemies evolve. But how exactly does the Helios work, and what are the three faces everyone is talking about? The three faces of Helios: hard kill, soft kill, and the surveillance eye. At first glance, the Helios system seems small. In fact, it looks about half the size of the CIWS, which was intended to be there. But much like many small things in life, it packs a powerful, tri-functional punch. So, let's explore what our enemies can expect. First, there's the hard kill laser aperture, or main gun. Located at the bottom of the system is the largest circular lens, the main aperture. It is where the primary 60 kilowatt high-energy laser, or HEL, fires from. It is a solid-state fiber laser, which is both more efficient and more rugged than chemical lasers the Navy experimented with decades ago. Its principal, hard-kill engagement, is thermal destruction. To put this into perspective, imagine a small boat or drone. Once the laser hits it, it will melt the metal, causing all the internal electronics to melt and ignite. But it's the speed of the laser that's the biggest differentiator. If a drone travels at 100 knots, it might be miles away, and a conventional missile will need to project its path. The laser beam reaches it in seconds, referred to as dwell time by the Navy. It literally means that when a swarm of drones is approaching, a simple scan of the laser can wipe them all out, almost like using bug spray to kill a swarm of flies. And all of this before a single missile is even fired. Then, there's the integrated tracking and targeting optics. Located high above the main aperture are two more circular lenses, which are the tracking and targeting components of the Helios. Known as ISR, or Intelligence, Surveillance, and Reconnaissance Sensors, they are responsible for tracking and targeting. Now, the Navy is yet to confirm which of these optics perform which role, but we can infer based on physics and operational requirements what they are responsible for. First, the tracking module is likely the smaller circle, responsible for acquiring a wide field of view and maintaining course lock on a target. Its job is mainly to provide tracking data for the fire control system. The larger circle is possibly the targeting or fire control module. Its job is to function not as a killing blow, but as a lethal, illuminating laser to achieve a precise lock on a specific point of a target. It ensures the laser remains perfectly focused, compensating in real time for atmospheric turbulence, the ship's pitch and roll, and the target's movement. This is what makes it a weapon, and not just a laboratory experiment. Even more, these two modules are integrated to work seamlessly with the ship's AN Spy-1 radar through the Aegis combat system. Thirdly, there is the Soft Kill Dazzler, CISR. Located to the right of the main laser is a small trapezoidal structure, which houses the counter-UAS-mounted ISR, CISR subsystem, including the Dazzler. This isn't a lethal part of the system, but a non-lethal defense measure designed to render the target useless without physically destroying it, known as the soft kill. This system projects a high-intensity, modulated light beam into the electro-optical and infrared sensors of an adversary's drone or surveillance craft. It completely saturates the camera or sensor array, rendering incoming drones incapable of reaching their targets. It is nothing new and has been deployed on other Navy ships, such as the Odin system, but this is the first time it has been seen on a weapon with a hard kill ability. Finally, there's the surveillance camera, often referred to as the best eye on the ship. As shocking as it might sound, historic destroyers lacked a dedicated high-definition thermal surveillance camera for decades. To work around this, most crews used the 5-inch gun camera as a navigational aid, especially for battle damage assessment. The Helios' sophistical optical tracker and sensor suite doubles as a long-range intelligence, surveillance, and reconnaissance (ISR) camera. Lockheed Martin has stated that this system is the most accurate electrical-optical sensor on the ship. Essentially, it is the most complete weapon system on any ship. The question now is, how does this give the U.S. Navy an advantage in warfare? The strategic imperative and reducing the cost curve. The success achieved by the live-fire drill wasn't just a matter of scientific curiosity, but a matter of urgency. As the geopolitical landscape changed, especially around the Arabian Peninsula at the start of 2025, this technology has become ever more important. One such example is that of the near-constant barrage of Houthi-launched drones, anti-ship ballistic missiles, and anti-ship cruise missiles. The United States has confirmed at least 60 intercepts, which, if done by the standard SM-2 or SM-6 weapons, would cost the Navy billions of dollars. To put this into perspective, an SM-2 missile costs more than $2 million per shot. A high-end SM-6 costs nearly $4 million. The Iranian-designed Shahed-136 drone, the most common threat, costs an estimated $5,000 to $20,000 to produce. That's hundreds of millions, if not billions of dollars, to take out cheap, disposable drones. It might be effective, but it is economics at its worst. A tactical victory, but a profound strategic loss. It's almost like dropping a nuclear bomb on an anthill. But now, the Helios, when working in its full effect, will significantly mitigate this threat. It can easily deal with swarms of drones, instead of using a missile for every target, while the speed of light engagement ensures each ship has more kills per minute. Essentially, it renders these cheap drones useless. Then there's the fast attack craft, of which the navies of Iran and its proxies field large numbers. These FIACs are difficult for missiles to target and are often too close for comfort when they pose the most danger. The Helios laser can precisely target the engine block, bridge, or weapons station of an FIAC, causing a structural failure or catastrophic fire instantly, long before the boat can close the distance to fire its weapons. Since Helios has no need to be reloaded and can fire if it has a stable source of power, it is a must-have in contested theaters. It transforms the cost curve from one that favors the aggressor to one that makes mass-producing threats an exercise in futility. While the deployment and successful live-fire testing of Helios represent one of the most significant shifts in naval warfare, the way these sailors survive aboard a destroyer is something entirely different. I'm talking about toilets linked to the ocean and a secret program that protects their mental health. Check out this video to find out more.